In this course, you will be given an overview of several accessory components that are used in most hydraulic systems. You'll learn about accumulators, pressure switches, gauges, flow meters, and manifolds. These components are vital to proper system operation, and understanding how they are used in a system is an important part of this basic hydraulic course.
Accumulators are devices that store energy in the form of fluid under pressure. Because of their ability to store excess energy and release it when needed, accumulators are useful tools for improving hydraulic efficiency. Industrial hydraulic accumulators are typically classified as hydropneumatic. This type of accumulator applies a force to a liquid by using compressed gas. The two most common types of hydropneumatic accumulators are the bladder-type accumulator and the piston accumulator. The name of each type indicates the device separating gas from liquid. A hydropneumatic accumulator has a fluid compartment and a gas compartment with a gas-tight element such as a bladder separating the two. The bladder is charged through a gas valve at the top of the accumulator, while a poppet valve at the bottom prevents the bladder from extruding into the pressure line. The poppet valve is sized so that the maximum volumetric flow cannot be exceeded. To operate, the bladder is pre-charged with nitrogen to a pressure specified by the manufacturer according to the operating conditions. When the system pressure exceeds the gas pre-charge pressure, the poppet valve opens and hydraulic fluid enters the accumulator. The change in gas volume in the bladder determines the usable volume or useful fluid capacity. Now that our accumulator is charged with stored energy, watch it discharge and use the stored energy to accomplish work. In this learning, there are two types of pressure switches, the board-on-tube switch and the piston switch, shown here. This pressure switch consists of a micro switch, a spring, a mechanical stop, a push rod, and a piston actuator. External lights are often used to indicate that the switch has been activated. When pressure builds in the system, it enters the device applying force to the piston actuator. This energy is transferred to the mechanical stop, compressing the spring, driving the push rod up until it activates the micro switch. Pressure switches are used to open or close an electrical circuit when a predetermined pressure has been reached. The purpose of a flow meter is to measure flow. It is not bidirectional and acts as a check valve blocking flow in the reverse direction. The main components consist of a metering cone, a magnetic piston, which is held in the no-flow position by a tempered spring. Fluid first enters the device, flowing around the metering cone, putting pressure on the magnetic piston and spring. As flow increases in the system, the magnetic piston begins to compress the spring, indicating the flow rate on the graduated scale. As the number of connections in a hydraulic system increase, so does the possibility of leaky fittings. Hydraulic manifolds drastically reduce the number of external connections required. Manifolds used for modular valve stacking incorporate a common pressure and return port, with individual A and B work ports for each valve station. At each station, additional control valving may be added by sandwiching or stacking the valves vertically. This is accomplished without any external connections. Manifolds are specified according to system pressure, total flow, number of workstations, valve size or pattern.